All right, these are the notes for 3.2. Starting with the vocabulary, we're going to talk about a linear equations, a linear function, and a nonlinear function. So a linear equation is just an equation that can be written in the form y equals mx plus b. Okay? So it may not be in that form to begin with, but it can be rearranged so that it is in that format. And that's slope-intercept form. Now, m and b are numbers, okay? They're constants. Y and x would still be in the equation. So you have one y, you have one x, and you know it's linear. Nothing is to a power. It's not x to some power or y to some power. Now, a linear function is a function whose graph is a non-vertical line whoops, if I can, right, there we go. And has a constant rate of change. Okay? So nonlinear is a function that doesn't have a constant rate of change. It's not a line. Okay, so if we go to the 3.2 notes, we're going to compare linear functions versus nonlinear functions. Okay, sorry about that bell there. Okay, so a linear function, we're going to do fully linear and then we'll talk about the nonlinear. A linear function, you might get it in the form of an equation. Okay, so remember, it can be written, whoops, that's not one word, that's two words there. Can be written, I kind of write my words close together, as y equals mx plus b. Okay, it means you can rearrange it. So if I give you some examples of equations, we could have some that look just like that, y equals like 3x plus 2. Okay, that's in that form. But you might something where you have 2y equals 5x plus 8. Okay, now there's something in front of the y. It is still an equation of a linear function because I could just divide everything by 2 and then I have y equals mx plus b. You can have 4x plus 3y equals 12. These are just examples here. And again, I can solve this for y and I can get it to that form. There's one y, there's one x. If there's multiples, you could collect like terms. There's no power to either of those. So you might see something like this. Even though there's parentheses, I can still solve for y. I can distribute the 2, I can subtract 5, and I have it then in that form. Might have just a fraction in it. Still linear. That's m would just be the fraction there. You might get something with parentheses and something at the end. Okay, still I could distribute collect like terms and it would be in that format. So that is the types of equations you might get. That any of those would still be linear, and there's linear functions, and there's still going to be more. I just only wrote some examples. You might be given a graph and asked if it's a linear function. It has to be non-vertical, and it needs to be a straight line. Okay? So if I give you an example of a graph, let's draw my axes here. Okay, that way you know they're not my lines. I could have one with a positive slope. Okay, so that's a straight line. So it's a function. It's non-vertical. There's one with a negative slope. Now I can't have a vertical. I can't have one up and down, but I can have them going horizontal. Those would all be functions. They all pass that vertical line test. And then, let's see, for number 3, you might be given a table or ordered pairs. So ordered pairs, okay? And if you're given a graph, you can always write it out in a table or write out your ordered pairs as this. Maybe you're just given points or whatever, and that point is 3, 2. That point is 1, 1. And you can fill out a table and put it in numerical order for x's or whatever, and then see if it has a constant rate of change. Okay, so if I give you a table, now your tables can be written in multiple ways. I'm just going to write this one horizontally. Okay, and let's just say my x values are 2, 4, 6, 8. Let's say my y values are 3, 6, 9, 12. Okay, to determine the constant rate of change, I am going to see, okay, what did I add to this number to get to the next x? So I added 2. I added 2. I added 2. So my x's have a constant rate, but I have to make sure both x's and y's do. Okay, so I added 3. I added 3, and I added 3. Everything is constant rate of change, okay? This really just gives you your slope. It's the rate of change of the y over the rate of change of the x, so it would be 3 over 2 would be my slope for that. Therefore, it's linear. Okay, so now let's talk about nonlinear functions, okay? So for their equations, you could have multiple different things. You could have square roots of x or some variable. Sorry about that. You can have x squared. You can have any power. So that could just be any power. And I wrote kind of big. You could have a fraction. So 1 over x. Okay. Or any variable in a denominator. Okay. So if I give you examples of equations, like x cubed minus 4y equals 27. I could solve that for y, but I'm still going to have an x cubed. So that is not linear. 3y plus 1 over x equals 2. Again, I can solve for y, but x is now in the denominator. It will not be linear. Y equals 6 plus 3 square root of x. And again, that's already solved for y. X is still in the square root, so it cannot be linear, okay? So that's the easiest way to tell with equations is the x just x, or is it in the denominator, or is it to a power or under a root? And now for their graphs, it's obvious. It's just not. I say it's obvious, but it's just not going to be a straight line. So if I draw a graph over here, I'm going to give you 2 examples of tables. That's why I'm giving you the space here. Draw my axes. Okay. You might get a quadratic. Okay. Cubic actually looks, how about we do that since I give you a cubed? Looks like that. Okay. Well, that's not straight line. It has this little wiggle in the middle. You might get a quadratic. That's x squared. You might get a square root. It's going to look something like that. Okay. One that's not listed, I didn't list here, but is still, it would be an absolute value. It would be a v. Okay, that's not linear. So those are just some examples of what graphs would look like. You would say not linear. And then for the ordered pair or table, oh, I'm just writing order. Okay, it just has no constant rate of change. So maybe a couple of tables here. So if I give you x comma y, and I give you, let's go 1, 2, 3, 4, 1, 8, 27, 64. I'm going to go ahead and write the other one. And now you could also have a table that goes up and down. You might even have the lines, where you have 1, 4, negative 3, 7, 2, 4, 6, 8. Okay. So if I have all of these, let's do this first table first. And I see that constant rate of change up top, it is constant. It's adding 1 each time. But on the bottom, I add 7, I add 19, I add 37. That's not constant. Okay? They both, x's and the y's, have to have a constant rate of change. And then if you're given a table vertically like this, well, let's see, I add 3 to get from 1 to 4. I subtract 7 to get there. And then I'm going to add 10 to get there. Okay? Not constant, even though the y's are. They add 2 each time. But since they both aren't, then I know it is not a linear function.